In the next few examples, we want to take a look at using the properties that we've established, those different rules, and see how they can help us simplify expressions with exponential pieces. In example 5, we have c to the 5th power times c to the negative 7th power. Using the product rule, we know that this will become c to the 5th plus negative 7 or minus 7, whichever way we want to write that. That will give us c to the negative 2nd power. And then we're told in the directions here specifically, we want our answers to use positive exponents. So we'll use that negative rule for exponents to rewrite this as 1 over c squared. Another way to approach this problem would be to start off with using that negative rule. So the first thing we could do is rewrite this second factor as 1 over c to the 7th. We can make anything a fraction, any number a fraction, by putting it over 1. So this tells us that what we have is c to the 5th over c to the 7th. And then we would use the quotient rule. We would subtract those two exponents, getting us to c to the 5 minus 7 power, getting us to the same place where this becomes c to the negative 2, or 1 over c squared. So there are different ways to approach these problems just depending on how we apply the rules, and either of those two approaches would be valid. In example 6, now we have something where we would look at using the quotient rule. This would become x to the 6 minus 7, which would give us x to the negative 1 power. But again, we want our answer to explicitly use positive exponents. So we would use that negative rule to flip this over as 1 over x to the 1st power, or more simply just 1 over x. In example 7, we have a power raised to a power, so we'll multiply those together. So this will become negative 6 times 10, or t to the negative 60. And then making sure we're again using only positive exponents, we would flip this to become 1 over t to the 60th power. For the remaining problems in this section, we can write our answer using positive or negative exponents. So we just want to be sure we're paying attention to the directions in any homework, quiz, or exam problems, and knowing whether we explicitly have to use positive exponents or either version is the same. That rule won't really matter, that direction won't really matter for example 8. Here what we'll do is just apply that square to both of these factors individually. So we could rewrite this as b cubed squared times c to the 4th power squared. And then we have a power raised to a power, so we'll multiply those together to get b to the 6th times c to the 8th. In example 9, we've got w to the 0 power, which we know is just going to be 1. So this is going to be 1 times x to the 5th raised to the negative 1st power. Multiplying anything by 1 is inconsequential, so we could just drop that out. This is just x to the 5th to the negative 1st power. Power to a power tells us we would multiply that together to make this x to the negative 5th. And now, since we can use positive or negative exponents, we could enter that as our answer, or we could flip this over to write it as 1 over x to the 5th power. Both of those answers would be correct for this problem. In example 10, we have m to the 4th power over n to the 0 power. It's important to note here that we have different variables. So those properties that we introduced before won't apply here. We can't subtract those exponents because we don't have a over a. We have a over b, or m over n. We have two different variables. The properties that we established before, like the quotient rule, work whenever we have the same base, the same letter being raised to a power. So in this case, nothing happens to m to the 4th power. N to the 0 power becomes 1. And our final answer is m to the fourth power. In example 11, we have 2 to the third power, or 8, in the numerator. And in the denominator, we can rewrite this as 3 to the negative 2 power times a to the negative 2 power. The first thing we'll do is take care of this 3 to the negative 2. So we already established that if we have a to the negative n, that's the same thing as 1 over a to the n. And sort of the inverse of that works. If we have 1 over a to the negative n, we can rewrite this as a to the n over 1. So we take the reciprocal of that expression either way. So we can rewrite this as 8 times 3 squared over a to the negative 2, meaning in the numerator we have 8 times 9, or 72, over a to the negative second power. Since we can use negative exponents, we can leave our answer like that, or we could flip that a up to the numerator and write this as 72a squared. Next we have y to the seventh to the third power. So we'll use the power to power rule, multiplying those together to get y to the 21 divided by 14. We can change that division symbol to a fraction to make this y to the 21st power over 14 as our final answer.